This is A2 beta Now we're going to start with the slideshow in the middle. That's the four-step process. Don't worry about it. Don't write it down. It's covered in the template. So here's an example. Ready? A recent poll of 738 randomly selected cell phone users. Done. There's the first condition. They were randomly selected. It's an SRS. 170 of them said they walked into someone or something while talking on their cell phone. Construct and interpret 95% confidence interval. So ready? If this is May, you get 1 point for that interval. You get 1 point for the interpretation. You get 1 point for identifying what the parameter is and what the test is, and you get 1 point for the conditions. So if you just write the interval, 1 out of 4, you're on your way to it too. So here's how the textbook rolled this out. This is the first 2 lines of the template saying it's a 95% confidence interval for P, the true proportion. Here are the conditions. Ready? SRS. You can literally just write SRS. 10%. The sample is less than 10% of the population. So we don't have to worry about that we're sampling without replacement. 170, because we took like 170 to 738 times 738, we can get 170. And 568 are both greater than 10. So we can assume that this is going to be approximately normally distributed. Now, here's what happens. This is just 1 point for this. P hat, sample proportion, is success over total. It's 2/3. Now what are you doing? You're getting the center, and you want a 95% confidence interval. Doing 1.96 steps left and right to the standard error, which is success times failure, and you get this, which means it looks like this. 0, 1.96, and negative 1.96. Because we're counting out to the width of the confidence interval. Now, we're not just going 1 standard deviation left or right. The reason we got 1.96 is that leaves 2.5% in each tail. Graph symmetric, so that means 95% in the middle. Now, underneath that, what do you have? You have 23%, which is the proportion of people admitted to walking into someone. Add or subtract 3%. That's what this looks like. So what we've been doing up till now is marking up the curve and saying, what's the data point, 1 standard deviation. Now we're talking about standard error, but the same idea. 1 standard deviation to the right and left. Well, now, instead of worrying about 1, we're going all the way up to 1.96 and negative 1.96, because that's going to give us the width of the confidence interval. And the interpretation is, you are 95% confident that the parameter is between 20 and 26% of people that admit to walking into someone while talking on their cell phone or texting. What does that mean? If you took all possible, you took many, many samples of size 738, 95% of those confidence intervals would capture the parameter. That's what I was talking about here. This exam tip. If you just build the interval, your score is, in fact, let's back up and show you how to build the interval. So how about if we do this on the calculator? Ready? Take out your calculator and go here. Stat, test. Now, that stat test menu is very intimidating. There's a lot of stuff. But we can break it in half because most of the stuff there has either a Z or a T. You have to understand, Z's go with proportions. T's go with means. We didn't get to means yet. So everything we're doing is proportion. So when you're looking for something to use for proportions, you'll have to have a Z there. We're going to scroll down to A, which is a 1 proportion Z interval. There? And when you click on A, you're just typing this in here. Ready? X is 170, N is 738, and you want a 95% confidence interval. And it's going to spit this out right here. Okay? So that's the point on the AP test. That's so easy to type that stuff in. All you got to do is find the correct program to use on the menu. But you're not getting rewarded unless you do the rest of the question. Identify the parameter, identify the conditions, and interpret what that means. But people don't do that. They just write that interval. Okay, so there are no guidelines for statistics. In calculus, they tell us 3 decimal places. Good? So the issue is, I would just stick with 3 decimal places in statistics, unless the problem is about money. And then if it's money, I would take it to 2 places and just leave it at that. Okay? So if you take it to 3 places, another kid takes it to 4, they're not going to get a better grade. So there was the tip. This is working backwards. So how about if we identify the most economical sample size? If we know the margin of error we're willing to accept, then we can use algebra to identify the sample size. Now their algebra is a little convoluted here, but it makes the point. So this is your margin of error. Now you should not need a formula sheet for this. What does this mean? The margin of error is here. Okay, what happened? Did you get that? It's the Z-score, Z asterisk. Why? Because it's 1.96 if it's a 95% confidence interval. And if it's a different level, there'll be a different Z-score. That's what the asterisk means. Times the standard error, which is P hat times success times failure divided by sample size. This is one step. We want Z steps. Whatever the Z score is for that confidence level, and that gives us the width. So if we know that, if we know this, and this, and this, ready? Variables, 1, 2, 3, 4. That's P hat. If you know 3 of them, you can solve the 4th one. Except what? Well, you don't know P hat. Like, you're trying to do this. I want to get the sample size in ahead of time. So you decide what margin of error is acceptable. You want to know the sample size. You're not just randomly sampling people because it's expensive. But then you back up and say, well, wait a minute. I don't know what P hat is. Then you use 0.5 because that would give you the greatest margin of error. Now, why is that? To get this. I've got P and times 1 take away P hat. Yes? And that's the numerator for the margin of error under the root sum. I want that to be as large as possible, because then I won't mistakenly have a margin of, I won't mistakenly underestimate the sample size. So we can do this by calculus. That would give you, we'll take out the hats just for, that would give you P take away P squared. I want to maximize that. So what do? You take the derivative with respect to P. You would get 1 take away 2P, set it equal to 0. Yes? No, it's gracefully the catch. But, ready? Then you would get 1 equals 2P. P equals a half. So the most conservative value to put in there would be 0.5. And if you put 0.5 in there, you would not risk having your sample size be too small. You don't need the calculus. You just need the 0.5 to maximize that. We can show you that on the calculator. If I do this, ready? What was your numerator? The square root of P times 1 subtract P. So I'm using X's because I'm in function mode. Yes, and I go to table set. Start at 0, make your delta table 0.1. This is the numerator, remember? The greatest numerator is here. The value is 0.5. So you don't need the calculus if you can use your calculator to see that that's confirming that 0.5 is what we're going to use. So they're saying you could do a pilot study, but ready, that's a little dangerous. We're just better off using 0.5. The margin of error is greatest when P hat equals 0.5. So this guess is conservative. So here's the example. The company has complaints. They want the proportion of customers who are satisfied with their customer service. She wants the estimate to be within 3 percentage points. So you're looking at this thing. 95% confidence level. They want the width here to be 3 percentage points. Now, coincidentally, that's what it was on another problem. But they want the margin of error to be 3%. That's it. Okay? So how could you find N? So see if you can follow. Now, this works a little convoluted. That is the step just to one side. Yes? Because what do you do with this number? You add or subtract this from the center. So this is the standard error multiplied by 1.96, you get the margin error. But we want this to be less than or equal to 3%. But we have values here for everything except N. You can solve this for N, that's your unknown. So what did they do? They divided both sides by 1.96. Then they squared both sides. Then they multiplied both sides by N. They divided both sides by that amount on the right. And you got this, 1,068. Ready? You can't round it. You have to round it up for the minimum sample size, okay? Because if you rounded it down, you would have a larger margin of error, okay? So you need 1,068 customers. But this is important because if you're doing this, you need to speak to that many people to get the margin of error you want. You don't want to speak to 2,000 people. Sampling's expensive. You want to identify what's the minimum sample size I need to get the margin of error that I'm comfortable with. So, there are the bullet points. Please, here's the big deal. You are doing a confidence interval for a proportion. That's what the section's about. So, we're going to pause the video while you go to 3 questions. Ready? 39, 47, and 51. 39 and 47 have the same data set. 39. Ready? What is the parameter? Well, you got to identify it. That's the true proportion of seniors that are planning to go to the prom. What are the conditions? Simple random sample. Your sample size is less than 10% of the population. You're going to sample 50 kids, and there's 750 seniors there, so you don't have a problem that you're sampling without inflation. 72% say yes. Okay, so 36 is greater equal to 10. 28%, 14 is greater equal to 10. So you can assume that this would be approximately normally distributed. Here's the calculator, but what is it doing? It's saying, here's success over total, 36 over 50. It's a 90% confidence interval. So the critical value would be the z-score that leaves 10% in each tail. Good? On your calculator, go here. Second distribution, 3. Inverse norm. You want 0.05. 0.1, enter. You got negative 1.645, yes? You get a different critical value. It's a 90% confidence interval. Times success times failure over total, over the sample size. So you got 72%, add or subtract about 10.5%. So the calculator is telling you 61.5% to 82.5%. You're 90% confident that the true proportion of seniors planning to go to the prom is in this interval. Well, it helps you with budgeting. It helps you, you're getting a head start on your plan. Then 47. 47 is, well, how many seniors is that? So we said, okay, 61.5%, 82.5% times the population. So you're talking about an attendance between 462 and 618 seniors. What we did was a size change of that, of magnitude 750 to see how many people, not the proportion. Okay. So we're going to pause the video again, and then the problem you have to go to is 51, which is about solving for n, the sample size. Okay, so for 51, so I just did the algebra a little differently than they did it. It's a 90% confidence interval, so that is your critical value, 1.645. The margin of error you want is 4%. The safest way to get that is to put in 0.5 for p hat. Okay? So now what? Well, if you square everything, you square this, square both sides, and then I did 2 steps in 1. Then I multiply both sides by n and divided both sides by 400 squared, you would get this. So the minimum sample size is 423. If you want the margin of error to be no larger than 4%, you would have to have a sample size of 423. Okay. Now, that question has been on the AP test multiple times.